mini quiz. So they have a 10 volts supply here, and they are pushing a current I naught, and this is some circuit. So how do you think the circuit will work? The same way which I told. You imagine a capacitance here, some C. You are pushing I naught current into this node. I naught is zero point 0.5 milliamps. This will increase this node potential. Okay. The moment the VGS of this bec- is VGS of this becomes greater than VTH, current starts to flow in this transistor M3. Okay. What is the current flowing in M naught? The
Point five
current here is
zero.
0.
0. So current flowing in M naught is zero point 0.5
Point five
milliamps.
milliamps.
This is fixed. So how will the current will flow? This node potential increases. This node potential goes up. This node potential goes up, and the current flows into
Only two.
M3. And current flows into M3, and this node potential will be increased such that this VGS is enough to get this zero point 0.5 milliamps of current. Getting this up.
Can you repeat it again?
See how this circuit is working is you have a current source of zero point 0.5 milliamps, and this is connected to a node. Initially, for the current to flow in this MOSFET, you should have some VGS, which is the cause. If you have that VGS, the same zero point 0.5 milliamps of current can flow in M naught. Okay,
Okay, okay, correct.
so that is happening by increasing this node potential. You will have an internal parasitic capacitance here at this node, and this node potential increases, and by that VGS of M3 increases. That means VS also increases because you are putting some current into this node, I2 current. So this node potential also increases. That means this gate potential of M naught increases. This will provide VGS for transistor M0, and the zero point 0.5 milliamps of current will flow in M naught. Is it fine?
Oh, yes, no, yes. Now understood. Yes.
Okay. Now we know that there has a feedback, and the current flows in M naught. So from this we can find out the VGS of M naught. Okay, for that we have a simple formula. This is from the current equation. ID is equals to half mu on Cx
Omega by L.
W by L into VGS minus VT whole square. From that you will have this direct formula. VGS is nothing but VT plus square root of 2ID by mu on Cx W by L. If
So not.
you put the numbers given in the question, you will get VGS as 1.7 volts. So the question they have asked is we should find the minimum potential at this node potential V naught for M3 to be in saturation, or it to be work as current source. Okay, now we know that this node potential is fixed 1.7 volts.
VD also 1.7.
So what will you do generally? This is 1.7 volts. Zero point 0.5 milliamps is flowing in M naught. So zero point 0.5 milliamps will flow in M1, M2, M3. and same VGS 1.7 volts, 3.4 here, and VD minus VT. You will put 2.7 volts as answer, and your answer will be wrong.
So yeah.
Okay,
Okay.
that's what we all did.
Okay.
But the catch is here. The catch is in this particular area. So we'll check that. All of you agree that M2 is in saturation, right? Everyone agrees, right? Okay. For it to be in saturation, first of all, it should satisfy the condition. It should VGS should be greater than VDH. Then saturation condition will follow automatically because VG and VD are connected. See, if you see for saturation, there are two conditions. One condition is VGS should be greater than VTH. This is first turn on condition. And then second condition is VDS should be greater than VGS minus VTH, or VD should be greater than is equals to VG minus VT. So this condition follows automatically because drain and gate are connected. This condition should also be satisfied. The same thing I have written above. For M2, VG is 1.7 volts,
Vx is Vs.
Vs is Vx,
Greater than.
and VT is zero point 0.7 volts. If you simplify, it is coming out as Vx should be less than or equals to 1 volt.
Vs is equals to.
But for M1, VGS condition is satisfied. It is already 1.7 volts.
Uh,
For M1 to be in saturation, it has to satisfy the second condition. That
uh,
is, Vx should be greater than or equals to VGS minus VT. Here, Vx is nothing but VDS for M1. VGS is 1.7 volts and VD is zero point 0.7 volts. So it is coming as Vx should be greater than or equals to 1. So this condition is not possible because if you satisfy this condition, your M2 transistor will not be in on condition itself. So from this we can conclude that we
Vx is
transistor M1 is in triode region or
is
linear region.
So, but
Does anyone have any doubt?
when the Vx is equal to one at that condition,
That condition they both will be in saturation.
both will be in saturation.
Yes.
Okay. Hmm.
Hello.
Ah, no. Okay. Okay.
Okay. So from this you can get the node potential Vx by applying KCL. The both are in series. M1 and M2 are in series. So you can apply KCL, write current equations in triode. This triode equation, this is saturation equation. You will get a quadratic equation, and if you solve, you will get Vx as 0.292 volts. From this, we can find out the current flowing in the transistor M1, M2, M3. Okay,
mm.
we know that M2 is in saturation, so we know the formula half mu on CXWL into VGS minus VT whole square. VGS is 1.7 volts. Sorry. Uh, VG is 1.7 volts.
V
VT is 0.7 volts. And Vx is 0.29 volts. So you will get a current of 0.25 milliamps. So here zero point 0.5 milliamps current is flowing, and in this branch 0.25 milliamps of current is flowing. Okay,
mm,
any doubts?
Fine.
From this you can find out the VGS per corresponding ID. Same formula, VT plus square root of 2 ID by mu on CX W. So you will get VGS as 1.4 volts. So the node potential here is 1.7 volts and VGS is 1.4 volts. So the potential here is
3 volts.
3.1
1.
volts. What is the condition for saturation for M3? VD should be greater than or
VT should
equals to
be equals to greater than PG minus VT.
VG minus VT. So it should be greater than or equals to 3.1 minus 0.7, which is nothing but 2.4 volts. So V naught minimum is 2.4 volts. Okay, this is the part one they have asked. What is the minimum V naught required so that output current I2 behaves like a current mirror? This is 2.4 volts. Then current I2 of for V naught is equals to 5 volts. Current we found out already. See, V naught min is 2.4 volts. If it goes from 2.4 to 5 volts also, the current will not change
Should same.
because it is in saturation.
Saturation region.
In saturation, the current will not depend on
Uh,
anyone.
VDS.
VT.
VDS.
VDS. VDS.
Current
Does not
will
depend
not
on.
depend on VDS. So, third part is to find the output resistance. So,
No. ఏందన్న అంత చేసావు?
hmm. So to find the output resistance, what I am doing is I am dividing it into subparts. What I will do is I will take this part as a subpart. Okay, and I will find the resistance looking down at this node. Okay,
Mm.
that will make our life easy. So I am taking this part. So we have this part, and I am doing small signal analysis. So here I will replace M2 transistor with its small signal equivalent GM2 VGS. Here VG is VT, and I am taking this node as Vx. So GM VGS, GM2 into VT minus Vx, and for transistor M1 it is VGS is VT. So the current is GM1 VT, and you have resistances from drain to source RO2 and RO1. So You apply KCL at VT,
VT minus
you
VX by
will
R
get IT as the
plus
sum of
GMV
these two currents.
leaving కాబట్టి
VT minus the current flowing in this branch is VT minus Vx by RO2, and the current flowing in this branch is GM2 into VT minus Vx. You group the terms with VT Vx, you will get this equation. Then again you apply KCL at this node potential. Again, the sum of these two currents also is IT. So IT is the current flowing in this branch Vx by R1 plus the current flowing in this branch GM1 VT. So you will get this equation. These all are simplifications. This is
VT by
math.
IT
So as you know, R equivalent is
1 by
VT by IT.
okay.
You will get this equation RO2 plus 1 plus GM2 RO2 into RO1 by 1 plus GM2 RO2 into 1 plus GM1 RO1. This is simple math. You can solve it, or at the end I will give PDF also. So the main thing is getting these values RO2, RO1 and all. So we know that M2 is in saturation. So we can write directly that
1 by
RO2 is 1 by lambda ID. But M1 is not in saturation. How will you find that resistance? So the thing is, to find out the resistance formula is 1 by dou ID by dou VDS. You have to differentiate the current with respect to VDS. When it comes to saturation condition, the current is given as ID into
lambda
1
ID.
plus lambda VDS.
Uh,
If you differentiate with respect to VDS, you will get lambda into ID.
It will be 1 by
So,
lambda. Right?
yeah. I'm doing that only. This is dou ID by dou VDS. Dou ID by dou VDS is lambda ID. 1 by dou ID by dou VDS is 1 by lambda ID. Okay. But whereas in triode region, the current is given as K into VGS minus VT into VDS minus VDS square by 2. Okay. If you differentiate with respect to VDS, you will get K into VGS minus VT minus VDS. Okay. Hello.
అన్న అన్న కట్ అయిపోయింది మళ్ళీ
Yes,
ఒకసారి.
yes.
Adik.
అన్న
Hello, Sadik.
అన్న అన్న కట్ అవుతుంది ఒకసారి చెప్పవా మళ్ళీ ఐ మీన్ ఆర్ నాట్ తర్వాత ఇంకా నాకు వినపడలేదు ఏమి
See, you understood this
యా
part? Calculation of R naught.
యా
Okay, this is in saturation. This is in triode region.
ఓకే
In triode region, the current equation is K into VGS minus VT into VDS minus VDS square by 2.
యా
So we have to differentiate it with respect to VDS. So you will get K into VGS minus VT minus
దాని తర్వాత
VDS.
యా అండర్స్టాండ్
So if you put these numbers, you will get 0.7 0.08 milli.
Hmm.
R naught is nothing but 1 by dou id by dou VDS. So you will get R01 as R naught 1 as 1.412K.
R not 2 years 200K.
Obviously, R naught 2 is 1 by lambda id, which is 200K. GM, anyhow, you know the formula for saturation. Mu is W by L into VGS minus VT,
Minus VT or 2ID.
which is 0.708 milli again. And again, what is the formula for GM? Dou id by dou VGS. So you have the current equation and triode K into VGS minus VT into VDS minus VDS square by 2. If you differentiate the same thing with respect to VGS, this term goes to 0, and VT into VDS term also goes to 0.
Then
K
K.
VGS into VDS will remain. VGS differentiation is 1 with respect to VGS, and you will get K into VDS, and you will get GM as 0.292 milli. For your reference, it is a standard what to say question in interviews or any competitive exam. GM in saturation is greater than GM in triode.
Hmm.
If you observe, GM in saturation
Is
was
KV.
0.708 milli, and GM in triode is 0.292 milli. And this is GM for transistor M naught, in which zero point 0.5 millicurrent is flowing. Because the current is higher in that, GM is also higher.
Higher.
So if you put the numbers, you will get the R equivalent as 2K approximately. That is for this circuit. For this circuit, R equivalent from here, from this point, you will get R equivalent as 2K.
Hmm.
So the our question will be simplified now. So will be remind with this circuit. The top transistor M3, M naught, and we have replaced the remaining circuit with R equivalent. Same way, you draw the small signal equivalent model for M naught. The current flowing is GM into VGS. I call this node potential as Vx. So the current flowing is GM into Vx, and you have a resistance from drain to source or not. And again for M3 same thing. GM VGS again a resistor in
And IT is equals to
parallel
VT
to that.
on 3 VT minus Vx by R
So in
not
the same way,
plus
if you apply KCL at VT, the current flowing from the voltage source, you have a voltage source here, VT, and the current flowing is IT. IT is nothing but sum of the current flowing in this branch, VT minus Vx by RO3, plus the current flowing in this branch, which is GM3 VGS3. If you simplify these things, you will get this answer. So the thing is here, it is not straightforward. The only thing you have to remember is you are getting a current here. The small signal incremental current, you are applying a voltage source here, VT, and that IT is flowing into this resistor, and it is creating a small signal voltage Vx. This Vx is affecting this V naught, M naught transistor. It is inducing a current of GM naught into Vx. That's what you should understand by this. You have a voltage source Vt, and from that voltage source, a small signal current IT is flowing. The IT current will flow through this R equivalent resistor, and it is generating a small signal Vx. The small signal Vx is nothing but VGS of M naught, and it is generating a current GM naught into Vx. This will generate node potential, which is nothing but minus GM Vx into R naught. And again, this will affect the VGS of this transistor. There is a feedback loop. I will send this PDF to you. You can see, is it in negative feedback or positive feedback. You can figure it out. So the main thing you should understand it. It's not straightforward. You can't put like you will have a standard cell rate. If you have some R naught here, the answer is GM R naught 1 into R naught 2 approximately. You can't do that. What is happening here is, hello,
Is it a positive feedback?
No.
yeah, I also have to check that. We can check actually.
Yes, we can break the loop.
Yeah, I'm breaking the loop here.
Hmm.
If I increase this potential, what happens to this potential?
It's potential.
Raja,
Which potential? That potential
VD also increase. VG increase, VD also increase.
increase that the current decreases, no, decreases.
so this node potential decreases. So what happens to this potential next?
The ID will decreases, then ID decreases.
It's also decreases.
Decreases. Decreases. VX decreases.
Okay, this
Decrease.
decreases. So it
Negative.
is in
Negative.
Negative feedback loop.
Negative
negative
feedback.
feedback.
Oh.
For those who are not able to get this, how they told increase, decrease, increase, decrease, you have to work out. Main thing is simple. If you don't know, you just go and check. This is VGS. If I increase VGS, ID will increase,
ID will increase,
and
VDS.
you are pulling out more current from this node. So this node potential will decrease.
Uh,
This done, and then here you are decreasing gate potential. So VGS also decreases. So your
Weeks also decreases.
VGS also decreases. So this node potential, the current flowing in Vx is nothing but I into this resistance. So I decreases. So Vx also decreases.
VGS decreases and
There is
ID.
also another way. So you can think of this as common source amplifier. Common source amplifier has 180-degree phase shift.
Wait.
So if you increase this, the output will decrease. And you can think of this as common drain amplifier. Common drain amplifier has a 0-degree phase.
Decrease.
So in that way also you can think as if you decrease this, this will also decrease. Okay.
So is this forming cascode configuration because common gate and common drain? And
Yes, it is a cascode actually.
అరే దాని గేట్ దానికి క్యాస్కోడ్ ఎలా అవుతుంది నా
Okay.
No, no, no,
Anyhow,
no, no. We have one doubt.
uh,
Okay. What is cascode now?
Cascode is to increase the output capacitance of a system or at a node. See, when you have a wait 1 minute.
You increase the gate because of an amplifier is there.
Let us say this is a common source amplifier. You will have a incremental resistance of R naught here, R naught here, and your gain will be minus GM R naught by 2. R naught parallel, simple. So with this, I have a limited gain. If I want more gain, either I have to increase GM or I have to increase the output resistance. I can increase the output resistance the another way. If I do this, the resistance in from here will be GM R naught square approximately. Down also GM R naught square by 2. Sorry, GM R naught square. So the equivalent resistance will be GM
G
R naught square by 2. Gain will be minus
G
GM R naught square
not square.
by 2. So here I have a gain of in of the order GM R naught. Here I have the gain of GM R naught square. So I have increased my gain. This structure is called cascode.
Okay, now, okay.
Okay, I got this equation. I'm putting these values which I got. So I got an answer of 28803. So answer given is 28684, which is approximately okay because we have taken some assumptions. I think it is fine. So the other part is
Incremental current.
wait 1 minute now. Sadiq, can you pause for 1 minute? I will come.
No pauses is there. What like pause?
Hello, hello.
No. But
You guys are following.
yeah.
Yes, Anna.
So we'll proceed with other questions now. So
Okay.
the part is they have told that they have increased current by 1 microamp, and we have to find that what is the change in output current, right? So since it is very small change, we will consider it as a small signal incremental current. So I'm taking it as a small signal current. I will replace the entire circuit with its small signal equivalent, and I will have this. So earlier also we have found this equivalent resistance. I'm replacing the entire circuit with R equivalent. So the node potential VG is nothing but
In minus
I
GMVG.
in minus GMVGS or GMVGS not into
No, can
R
you
naught.
speak a little bit loud? No, we are not able to hear properly.
Node is okay.
Ah, yes, fine.
Okay. So the node potential node voltage VG is the current flowing in this is I in current flowing is I in minus GM naught VGS naught. So the node potential VG is current flowing into the resistance R naught. So VG is nothing but I in minus GM naught VGS naught into R naught, and again Vx is
The
nothing but
current is this
GM3 VGS3 into R equivalent. Here the node potential here is current flowing into R equivalent. Current flowing is GM3 VGS3 into R equivalent, and VGS naught. VGS naught is nothing but Vx, and VGS3 is VG minus Vx. This is also simple math only. You can solve this, and in the final you will get Vx as this. I got Vx in terms of In. Then I can find out iode. I know the potential Vx. Then I can find iode by putting Ohm's law. Just Vx by R equivalent is nothing but iode. Iode is nothing but Vx by R equivalent. I have Vx by R equivalent. I will put this R equivalent. This R equivalent will get cancelled. So I will get this equation. If I plug those numbers, I got 0.491. The given answer is 0.5. Actually, they told that uh, in is 1 microamp. We have to find iode. So we got 0.5. 0.5 in 1 microamp, which is nothing but 5A minus 7. You divide and multiply with 10 so that you will get this 5A minus 7. Okay,
Yes,
is it
yes,
fine?
yes.
So the other part is we have to find the settling time.
ఓకే నువ్వు చెప్పింది ఇప్పుడు సెకండ్ ఆన్సర్ లాస్ట్ ఆన్సరా?
So to find settling time, go back to the circuit. See, this is the first order system. Can anyone say why it is a first order system?
వన్ సి విల్ బి దేర్.
Raja,
Because transfer function has one pole.
yeah, transfer function as well. one pole, but can you tell it from the circuit they have given? How can you tell that there is a one pole? You haven't found out the trans function, right?
నాకు తెలిసింది అది.
There is one capacitor loop.
వన్ కెపాసిటర్.
Yeah, there is one capacitor. There is one capacitor
నేను తెచ్చుకుంది
and
గుర్తుందా?
the equivalent resistance associated with this capacitor. Okay.
R
ఆర్సీ
equivalent.
ఇస్తే.
Yes, to form a pole, you should have a capacitance and then a resistance. So you have a capacitance and equivalent resistance here. You can compare it with the
వన్ ఆర్సీ.
first order system.
ఆర్సీ అంతే, ఫస్ట్ ఆర్డర్ అదే ఉండేది.
Let us say you have this
సి అంతే.
V in, V out. What is the transfer function?
1/SRC plus 1.
ఈక్వల్స్ టు
1 by
1 బై 1 ప్లస్
SRC plus 1.
ఎస్ఆర్సి.
1 by 1 plus here.
ఎస్ఆర్సి ఎస్సిఎల్
Okay.
అంటే
From this, if you equate denominator to 0,
Time constant.
yeah, time constant is nothing but
1 బై ఒమేగా పి ఈక్వల్స్ టు ఒమేగా ఆర్సి.
which is nothing but RC. So time constant is a point. Let us say I apply one unit step. If I apply one unit step, this capacitance will charge up to 1 volt. Let us say unit step is 1 volt, right? It has to charge up to 1 volt. It won't charge immediately, rather it will reduce. Okay, time constant is the time where it will reach to 63% of the final value. This time, and at 3 tau, let us say this is 3 tau, it will reach to 95%, and at 5 tau, it will reach to some 99% or something. Here, they are referring 5 tau as settling time. Okay, now to find the settling time, we need to find the time constant of the first order system. Then if we multiply it with 5, you will get settling time. Is it okay? That's what they have told. First order system, 5 times the time constant is settling time. Is it fine?
Yes.
So what I will do, I will go back to the small signal, system, and I will find out the equivalent resistance at this point. equivalent resistance at this point, and into that capacitance is given as 1 picofarad. If I find this R equivalent at this node, I can find the time constant. To find any equivalent resistance, simple thing is to find out the ratio of voltage by current. Apply a voltage source there. Find out the relation between that voltage and current. You will get R equivalent. R equivalent is nothing but V test by I test. To find this, just you need KCL and KVL. So from by seeing this, you can say that Vx is minus GMVT into
100K.
100K,
100K.
and also IT is
VT by
I am combining these two resistance 2K and
VT
200K.
by 2K
IT
20K
is nothing but
parallelly.
VT by 2K parallel 200K
It is coming inside
minus
that minus K
GM3
voltage.
VGS3.
Hmm.
So in place of VGS3, you can put so VGS3 is nothing but Vx minus Vt. You can plug this value in place of Vx, which is nothing but Gm naught into 100K into Vt minus Vt. If you put the terms together, you will get Vt by It, which is nothing but 13.88 ohms. To find time constant, as I told, you have to settling time. You have to just multiply it with 5. So you will get 69.43 into 10 to the power minus 12. So the answer given is 7 e power minus 11, which is okay almost, because we are not doing exact calculations. This part is okay, everyone. You should be able to do these calculations for any given circuit, any new circuit. So on the last question is when we are changing the input current by 1 microamp, what is the change in this node potential? In the question it is Vx, but I have taken it as Vy. So this also you have to just apply KCL
KC.
KVL. You put this circuit. We know Vx from previous small signal analysis. Sorry, this is Vy. I have taken it as Vy. So here, what I have done, I have applied KCL at node Vy
Vy by R naught
plus
1
Vy by R
plus
corresponding
GMVX minus
this
GM
current
Vy minus Vx by R naught 2 minus minus GMVX minus
current
Vy.
flowing here plus current flowing here
Vy ఒకసారి కామన్ ది మిగతా నెట్వర్క్
minus
పంపించు.
KCL.
Vy మొత్తం రాయి అన్నట్టు అన్నట్టు వచ్చి జిఎం మొత్తం నీ దగ్గర మళ్ళీ విఎక్స్ ప్రీవియస్ తీసుకో మొత్తం ప్రీవియస్ తీసుకొని వేసేది
All you will
అయిపోయింది.
get. But the main thing is I have taken Vx as 1 milli. Why 1 milli?
see.
So I out is nothing but Vx by R equal. Okay. I out we got is zero point 0.5 milli, zero point 0.5 milliamps. R equivalent I got is 2 Vx is
No voice on the.
IOT into R equivalent.
okay.
Fine, fine.
Okay. Nothing but IOT into R equivalent. IOT we got as uh, what 0.5 micro into R equivalent is 2K, nothing but 1 milli volts. We got this lesson Vx into 0.317. I'm putting Vx as 1 milli. I got this answer. Given
No,
circuit.
no,
The
ఒకసారి
answer
సెటిలింగ్
is
టైం
0.
ఆన్సర్ చూపించవా?
Settling time.
ఆ,
Settling time.
5 ఇంటూ టో ఇచ్చావా?
8 times of tau.
5 టైమ్స్ ఆఫ్ యా పైన ఆర్ ఈక్వలెంట్ తీసుకొని ఒకసారి పైకి రావా, పైకి రావా? ఓకేనా, ఓకే ఓకే
R
ఫైన్
equivalent to 1.
ఫైన్ ఫైన్ యా ఫైన్ అర్థమైంది అర్థమైంది.